Boleh. Mengumumkan ketibaan Profesor Insinyur Dr. Abdul Aziz Abdul Rahman, Timbalan Naib Chancellor Hal Ehwal Pelajar Universiti Malaya selaku pengerusi majlis pada pagi ini, dan Profesor Dr. MOHD RAFIE JOHAN. Hadirin dipersilakan duduk. Majlis menjemput Tuan Haji Muhammad Asri Muhammad Zain untuk mengetuai bacaan doa.
Assalamualaikum warahmatullahi taala wabarakatuh. Al-Fatihah. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin, hamdan hamidi, hamdan zakiri, hamdan sabiri, hamdan yuafi ni'mahu wa yakafu mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhika azimi sultanik. Ya Allah, ya Tuhan kami, sesungguhnya kami berhimpun pada hari ini bagi menyatakan kesyukuran di atas kurniaan-Mu yang tidak ternilai. Jadikanlah kami hamba-hamba-Mu yang sentiasa bersyukur, sama ada nikmat yang sedikit, lebih-lebih lagi nikmat yang melimpah ruah kepada kami. Ya Allah, ya Rahman, ya Rahim, sesungguhnya Engkau Maha mengetahui bahawa kami di sini ingin menimba ilmu-Mu yang sangat luas bagi mengembangkan potensi kami sebagai hamba-Mu yang Engkau redai. Justru berkati dan rahmatilah perhimpunan kami ini. Kurniakanlah kepada kami ilmu-Mu. Sinarilah hati-hati kami dengan cahaya dan hidayah-Mu. Semoga dengannya kami mudah menerima dan menghayati serta mengamalkannya. Ya Zal Jalali wal Ikram. Kurniakanlah jua kepada kami kesihatan anggota, kejagatan minda, ketenangan jiwa, kekuatan semangat. Semoga dengannya kami mampu mendepani cabaran, berdaya saing dan mampu mengangkat martabat diri, keluarga, masyarakat dan negara. Rabbana atina fid dunya hasanah wa fil akhirati hasanatan wa qina azabannar wa adkhilna jannatal abrar ya aziz ya ghafar ya rabbal alamin. Wa sallallahu ala sayyidina Muhammadin wa ala alihi wa sahbihi ajma'in walhamdulillahi rabbil alamin. Taqabbalallahu minkum.
Terima kasih Tuan Haji Muhammad Asri atas bacaan doa tadi. Assalamualaikum dan salam sejahtera. Profesor Insinyur Dr. Abdul Aziz Abdul Rahman, Profesor Dr. Muhammad Rafie Johan, Barisan Ahli Akademik dan Pengurusan Pusat Penyelidikan Nanoteknologi dan Pemangkinan Universiti Malaya dan hadirin yang dihormati sekalian. Selamat datang ke syarahan perdana oleh Profesor Dr. Muhammad Rafie Johan yang bertajuk Quantum Physics, Nanotechnology and Philosophy, an Exploration to the Inner Dimension of Life and the Destiny of Man. Untuk tidak melengahkan majlis, dengan segala hormatnya dipersilakan Profesor Insinyur Dr. Abdul Aziz Abdul Rahman untuk mempengerusikan syarahan perdana ini dan seterusnya memperkenalkan Profesor Dr. Muhammad Rafie Johan. Dengan segala hormatnya dipersilakan.
Bismillahirrahmanirrahim. Assalamualaikum and very good morning. Let me start this program in English. Perhaps later I can read the text that is prepared for me. Okay, to the students, I see many of them from. I'm actually very pleased to be here because Professor Johan is my fellow academic in Faculty of Engineering. Yeah? So he can be attributed to two big successes in Faculty of Engineering. First, he was responsible for probably initiating and moving the bio. I think when he was doing his PhD and we were struggling as students, I think I was there as well. So in that sense, we share a lot of common things. And of course, he was in engineering, later seconded to NanoCAD. Now, this Syaraan Perdana or inaugural lecture is a tradition that we want to keep. I think a lot of other universities are also doing the same thing. This is an befitting session, a milestone in a professor's life, where with this you stamp your expertise, your mark, your contribution to the knowledge and to the university, to the nation, and to the world. So I think I'm really proud to be here. Actually, I stand in for TNC Prof. Norsada, but I'm glad to do it today. Prof. Rafie, I'm glad to be here, Rafie Johan. Now, let me read this text now. Pada pagi yang bersejarah ini, kita berkumpul bersama-sama mendengar syaraan perdana oleh Prof. Dr. MOHD RAFIE JOHAN yang bertajuk Quantum Physics, Nanotechnology and Philosophy, an exploration to the inner dimension of life and destiny of man. I think very interesting topic. I can't wait to listen from him. Sebelum itu, saya dengan besar hati ingin memperkenalkan serba sedikit latar belakang Profesor Dr. MOHD RAFIE JOHAN. MOHD RAFIE diberi nama, lahirnya pada 24 hari bulan Mei 1968 di Solok Duku, Masjid Tanah, near to my kampung, Melaka. I'm from Semerbuk. Anak ketujuh daripada 10 orang adik-beradik, membesar dengan didikan yang tegas daripada bapa yang bergelar askar dan ibu yang besar hatinya dan penyayang. Beliau adalah anak kampung yang mempunyai impian yang besar. Ini adalah hasil dorongan yang tidak pernah putus-putus daripada kedua-dua ibu bapa yang begitu percaya dengan kepentingan pendidikan. He come from a big family. Mendapat pendidikan formal di Sekolah Kebangsaan Masjid Tanah dan kemudian terpilih untuk menyertai Melaka High School Program. Perjalanan pendidikan tinggi di UTM Kuala Lumpur dalam bidang kejuruteraan sivil hanya bertahan selama 1 semester. Dengan bulat hati beliau mengambil keputusan untuk mengikuti minat beliau dan meneruskan pengajian tingkatan 6 di Melaka High School. Memilih untuk meneruskan pendidikan di Universiti Malaya dalam bidang fizik dan berjaya menamatkan tahun terakhir pada tahun 1993 dengan kajian mengenai teori fizik berkaitan elemen zarah dengan menggunakan Feynman diagram di bawah penyelian Prof. SP Chia. Beliau dilantik sebagai tutor untuk sejarah dan falsafah sains di Fakulti Sains UM, yang mana beliau memberi keterujaan kepada beliau dalam bidang berkenaan. Di samping itu, beliau turut bekerjasama dengan Profesor Muhammad Riza Wahidin dan Profesor Muhammad Rasak Muhammad Arwada dalam kajian dan pembangunan theoretical model of atoms in the squeezing mode. Beliau kemudiannya dilantik sebagai pensyarah di Fakulti Kejuruteraan. There was a new thing then, physicists coming to engineering. Universiti Malaya sebagai pensyarah kejuruteraan bioperubatan pada pengajian Dr. Falsafah. Semua pengorbanan beliau dan keluarga akhirnya terbalas setelah beliau berjaya menamatkan pengajian Dr. Falsafah pada tahun 2005 dalam bidang teori bahan termaju, ionik, keadaan pepejal, di bawah seliaan Profesor Abdul Karim Aruf. Perjalanan karier beliau diteruskan sebagai pensyarah kanan di Jabatan Kejuruteraan Mekanik, Universiti Malaya pada tahun 2006. Beliau menjadi saintis pelawat di Universiti Cambridge dan dilantik sebagai penyelaras untuk program kejuruteraan bahan dan menubuhkan kumpulan penyelidikan kejuruteraan bahan nano. So he is also one of the early researcher in nanotechnology. So he has a lot of firsts. Kumpulan ini disertai oleh pelajar-pelajar sarjana dan doktor falsafah di bawah seliaan beliau dengan kemudahan 2 makmal penyelidikan. Pada tahun 2010, beliau dilantik sebagai Profesor Madya dan Profesor Kejuruteraan Bahan pada tahun 2015. Berkhidmat selama 13 tahun di Fakulti Kejuruteraan amat mematangkan beliau. Khidmat dan pengalaman beliau diperlukan di Pusat Penyelidikan Nanoteknologi dan Pemangkin NanoCAD pada tahun 2017. Beliau dilantik sebagai pengarah NanoCAD secara rasminya menggantikan Alhamdulillah Profesor Sharifah B. Dalil Sharifah B. Tanggungjawab yang pada mulanya dirasakan amat berat dan mencabar fizikal dan mental beliau, namun dengan semangat untuk membawa NanoCAD ke arah lebih baik, beliau berjaya mengemudi NanoCAD dengan kewibawaan tersendiri. And Universiti Malaya consider NanoCAD as one of the successful research lab. Thank you very much for your leadership, Professor. Saya merasa amat bangga dan semangat dan ketabahan beliau sehingga hari ini saya yakin dan percaya beliau mampu mengemudi NanoCAD dengan baik untuk mencapai misi dan objektif yang telah ditetapkan. Saya juga mengajak kita semua sama-sama berdoa kejayaan NanoCAD dan Universiti Malaya dalam melahirkan insan yang berilmu dan bermoral tinggi. Dengan segala hormatnya, sekarang saya menjemput Profesor Dr. MOHD RAFIE JOHAN yang juga kawan baik saya untuk menyampaikan syaraan perdana beliau yang bertajuk Quantum Physics, Nanotechnology and Philosophy, and Exploration to the Inner Dimension of Life and the Destiny of Man. Dipersilakan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih Prof. Aziz, Timbalan Naib Chancellor Hal Ehwal Pelajar dan juga memangku Timbalan Naib Chancellor Pembangunan. He is the most powerful TNC in UM. He holds 2 portfolio. Yeah? Pertamanya saya bersyukur kepada Allah Subhanahu Wa Taala kerana dengan limpah kurnia dan rahmatnya saya dapat berdiri di sini. Mak saya pun ada di sini, keluarga saya pun, ya. Rakan-rakan saya, pelajar-pelajar saya, ya. Alhamdulillah. Izinkan saya untuk menggunakan bahasa Inggeris, ya, untuk menyampaikan syarahan ini. Bismillahirrahmanirrahim. Ladies and gentlemen, distinguished guests, thank you for with me today. I want to share with you the topic that I have interest in from the very beginning of my studies. This is a topic that I believe, can motivate us, to see the dimension of life, from the physics perspective and also from the philosophy and even from the theology. First of all, what is reality? Everybody knows about reality. Well, let me hold this microphone. Is it this microphone is real? Of course it's real. Really, yeah? But this microphone is statics, yeah? If you observe from our naked eyes, yeah? From microscopic point of view, yeah, this microphone is statics. But if you look at from different angle, yeah? From nanotechnology, from microscopic point of view, they are not statics, yeah? So the atoms that build the microphones are always vibrates, yeah? The electron which is surrounding the nucleus, yeah, are always in rotations. So they are dynamics. So there is a degree of reality here from microscopic point of view and also from macroscopic of view. So which one is the most applicable to us? Yeah? So is it when we observe something, yeah? For example, our mind can influence what we observe. Yeah? For example, when we observe a big object, for example, what will happen to the objects? Yeah? And if you look at from the microscopic point of view, if you observe, for example, the electrons, yeah? So initially the electron is not exist. Yeah? But when you observe the electrons, yeah? So from the wave functions, they collapse and they become electrons. So there will be a relationship between our minds and our object that we observe. So it's completely different of view. Yeah? So this is what we call in quantum physics, yeah? The observer effects. Yeah? So, ladies and gentlemen, yeah, in order for us to understand what the reality is, yeah, so let me go back to the history of science. Yeah. So, in the 17th century, yeah, a French philosopher and mathematician, René Descartes, yeah, he proposed the mechanistic model of the universe. So according to Descartes, the universe is governed by the mechanical law. And Descartes, yeah, also proposed that mind and body are two separate entities. Yeah? So there is separable between mind and body, and there is no relationship at all between mind and body. So mind is one thing and body is another thing. Yeah? So this view continue, this is what we call mind on matter. Yeah? This view of Descartes has continued by Isaac Newton, a British mathematician and physicist. He discovered the calculus and very famous for his physical law. Of course, you learn first law of Newton, second law, third law, yeah, during your SPM. So according to Newton's, yeah, in the universe, yeah, we can completely make a predictions, repeatability, yeah, and also what happens, yeah, in the universe, yeah, can be predicted. Yeah? For example, if I want to going back to my hometown, yeah, yeah, by taking a bus, if the speed of bus is around 110 kilometers per hour, so I can reach, yeah, my hometown around 2 hours exactly, precisely. So meaning that, yeah, we can determine, yeah, the outcome, yeah, yeah, of the physical phenomena, yeah, using physical laws, yeah, through what we call Newtonian models. Yeah. So Newtonian model or classical physics, yeah, has dominated, yeah, physicists for a very, very long time. Yeah. And again, Newton, he followed his predecessor Descartes by assuming that, yeah, mind and body also is a separable entity, even energy as well. Yeah, energy we consider is not an object or matter, but for Newton, yeah, it is an object. It is a force which is acted, yeah, on the body. Yeah, so it is something physical. Yeah. However, yeah, this idea, yeah, has been challenged, yeah, in the 20th century by Albert Einstein. Yeah? So according to Einstein, yeah, energy and matter is really interrelated. Yeah? He came out with a relativity theory where energy can be transformed into light, or light can be transformed into energy. So energy and matter is interchangeable. And this is very contrasting view, yeah, with respect to the view of Newton and Descartes, where they are considered energy is a matter. Yeah. So again, yeah, Einstein also proposed that light, yeah, with the maximum speed, yeah, in the universe is 3 times 10 power of 8, yeah, meter per second. Yeah. Yeah, that light actually, yeah, has 2 different properties, yeah, which is light can be a character of matter and also it can be a character of wave. Yeah? While wave and matter is completely different character. How the two opposite character can be in one object? Yeah? So this idea strengthening by French physicist Louis de Broglie, where he come up with the formula lambda equals to h over p, where lambda actually is the character of wave, wavelength, and p is the character of the momentums of the particles. So wave and matter are interchangeable. There is characteristics of both properties in light. And this is also a challenge to the Newton Cartesian paradigm. So therefore, we have what we call wave-particle duality, where the wave and particle can be a character for light. So because of this series of events, so now there is a new branch of physics, what we call subatomics or quantum physics. Quantum physics, actually this is quantum physics. It is a subject or course that study the behavior of subatomic particles. So the subatomic particles such as protons, electrons, neutrons, if you want to go more deeper, so the proton actually is composed of sub-elementary particles such as quark, and quark has different kind of quark. There's a top quark, there is a bottom quark, and there is also the quark flavor. So this is the area of quantum physics. So when the quantum physics arises, so it challenged the classical physics of Newton's. So for example, the classical atoms, the classical atom here. So we have a model of classical atoms, where we have at the center here is a nucleus, and surrounding here is probably electrons. This is basically follow the planetary models in our universe. So if we look at this model, so this basically materials, almost solid stuff. Nothing immaterial exists here. But the model of quantum atoms, if you look at here, the center here is a nucleus, and it's surrounded by the electron clouds. So it is almost empty actually. 99% of this atom is energy. Only 0.001% is a material, is a particles. It is completely different compared with the classical atoms. So this is a comparison between a classical atom and a quantum atoms. So if you look at this here, so we have electron clouds, which is basically exist in a potential. They are not real, they exist in potential, meaning that they are energy, compared to the classical atoms, they are physicals. So, since our basic foundation is atoms, we are composed of atoms. Atoms combine become molecules, molecule combine become cell, cell combine become organs. So our basic foundation actually is almost nothing, or energy. So we are living in a potential actually, in a quantum field. So, however, subatomic particles, yeah, subatomic particles, they are not follow the macroscopic objects. Yeah, they have precisely using Newtonian models. Yeah, but for the subatomic particle, it's completely different. Yeah, so this electron, for example, yeah, can appear from nothing, and also can disappear. It can be everything. It can exist simultaneously. Yeah, so they are totally uncertainty. Yeah, for the subatomic particles. So when this electron, for example, yeah, interacted with the nucleus, they will possess their energy, or they will lose their energy, and they move toward the center. Yeah, they will appear and they will disappear, and they seem to show to over all the space, yeah, without regards the boundary of space and time. Yeah, so it is completely different behavior of subatomic particles, yeah, compared to a macroscopic object. So the question is, yeah, how could they be the subject, yeah, to one set of rules, yeah, and the thing that made up behavior according to another sets of rules? Yeah? How come we have different kind of rules for subatomic particles, while for our body here, macroscopic body, we are governed by another rules? Yeah? While actually we are based on the subatomic particles. Yeah? So this is a question rise, yeah? And there is a philosophical implication of this. Yeah? So while, as I mentioned just now, yeah, the behavior of subatomic particles are completely different. For example, when we want to observe, yeah, electrons, yeah, I'm the observer. I want to observe the electrons. Yeah? So what will happen actually, I will focus the energy towards the electrons. So electron basically non-exists. Yeah? So they exist as a wave function. So when I observe the electrons, so the wave function completely collapses and they become particles. So meaning that, yeah, we can create a new reality here, yeah, from something that does not exist. Then once we observe, yeah, so the electron exists. So this is the behavior of subatomic particles. Yeah? So what we call here is the observer effect, or the collapsing of wave functions. So for example here, this is wave function of the electrons. So once we do the measurements, yeah, for example, we observe, so the wave function will be collapsed, and there will be a position here where the electrons arise. Yeah? So new reality emerge after we do the observations. Yeah? So to be more clear, before observations, the waves are spread out over the space and time. Yeah? So meaning that they are not, electrons are not exist. Yeah? But after we do the observations, so the wave function is collapsed and they transform, become particles or become electrons. So meaning that we create a new reality, yeah, after we observe, yeah, the electrons. Yeah? So this is again have a huge philosophical implications. So there is a relationship between our mind, yeah, our minds, and what we observe. Yeah, it's something different compared to Newtonian and Descartes, where Newton and Descartes mentioned that mind and matter are completely separable. Yeah, are not really related. But with this discovery, yeah, this theory, yeah, mind and matter are not separable. Yeah, they are inseparable, but they are related, where the mind can influence the external objects to exist. Yeah? So we can have a potential to create a new reality out of nothing. Yeah? So this is very amazing and have a philosophical consequence. So the moment the observer looks for an electron, there is a specific point here in time and space where all probabilities of the electron collapse and the physical events occurred. Yeah? So with this, we can consider mind and electron, mind and matter cannot be longer considered separate. They are intrinsically related due to the subjective mind produce measurable changes on the objective physical world. Yeah? So, ladies and gentlemen, yeah? So what we are mentioned here is a quantum field. Yeah? It is beyond the boundary of space and time. And in the quantum field, there exist huge possibilities. Yeah? So there is infinite number of physical realities exist, yeah, in the quantum field. Yeah? So at the subatomic level, yeah, energy responds to our mindful attentions, and it becomes matter. Yeah? So the question is, yeah, how would your life change, yeah, if you learn to direct the observer effect and to collapse infinite wave of probability into the reality that you choose? Yeah? So if subatomic particle can exist, yeah, in an infinite number of possible places simultaneously, we are potentially capable of collapsing into existent and infinite number of possible realities. Yeah? So this is completely amazing. Yeah? So if you can imagine a future event, something is not happen at the moment, yeah? In your life, yeah, based on any of your personal desires, yeah, that reality already exists, yeah, as a possibility in the quantum field, waiting to be observed by yourself. Yeah? So if your mind, yeah, can influence the appearance of an electron, then theoretically it can influence the appearance of any possibility. That means that, yeah, the quantum field contains a reality in which, for example, you are healthy, wealthy, and happy, and possess all of the quality and capabilities, yeah, of the idealized self that you hold in your thoughts. Yeah? So with willful attention, repeated daily effects, so we can use your mind, yeah, as the observer to collapse the quantum particles into a desired physical event called an experience in your life. Yeah? So this is crucial to understand how you can cause an effect or make change in your life. Yeah? Ladies and gentlemen, now I want to bring you to another interesting aspects of quantum physics, is quantum entanglement. Yeah? So like everything else in the universe, we are connected, yeah, in a sea of information, in a dimension beyond physical space and time. We don't need to be touching or even in a close proximity, yeah, to any physical elements in the quantum field to affect or affected by them. So this is a serious implication concepts. Yeah? So because if you can wrap your mind, you or us that exists in a probable future is already connected to the you in this now, in a dimension beyond the space and time. Yeah? Okay. So, ladies and gentlemen, so every potential in universe is a wave of probability that has an electromagnetic field. That is including our thoughts and also our feelings. Thoughts come from our minds, feelings come from our body. Yeah? So if you consider thought as the electrical field and feeling as a magnetic field, both of them are wave. Wave. Together, how we think and how we feel will produce a state of being, which generates an electromagnetic signature that influence every atom in our world. Yeah? So we have a electrical field here and the magnetic field. When they are combined, they become electromagnetic wave, which is propagates in the quantum field. So if you could create a new electromagnetic field by changing your state of being, which match that potential in the quantum field of information, so it is possible that your body will be drawn to that event, or that event will find yourself. So our feelings and our thoughts, and they combine, so they become actions. But in order to match the potential in the quantum field, we need to have what we call the quantum coherence. So meaning that both field, the magnetic field and the electrical field, must be in a coherent phase. They are in the same phase. So when they are in the coherent phase, so they become amplified, and they can match the potential in the quantum field. While if they are in coherence, they are out of phase, then the material will not exist. So to change our state of beings, we need a coherence between our thoughts and our feelings. So our thoughts and our feelings cannot be in coherence. So for example, when your thoughts and feelings are aligned, such as when you hold clear, focused thoughts about your purpose, accompanied by your passionate emotional engagement, you broadcast a stronger electromagnetic signal that pulls you towards a potential reality that matches what you want. On the other hand, how many times have you tried to create something, thinking in your mind that the end result was possible, but feeling in your head that it wasn't. So you send the incoherent signals. So for example, when we pray, we dua, after we pray, so our mind has to send a signal, which is coherent with our feelings. So there must be a coherence in order for the prayer to be answered, the material to be exist. if you pray with your thoughts, is incoherent with what you feel, then your prayer will not be answered. Yeah? So if you change your mind, then you will change your life. Yeah? So mind and matter are inseparable in quantum field. So if you could change your mind, your thoughts, your feelings, and you make it them coherent, then you can change your destiny. Ladies and gentlemen, thank you for listening.
Tuan-tuan dan puan-puan yang dihormati, kini majlis mempersilakan Profesor Insinyur Dr. Abdul Aziz Abdul Rahman untuk membuat rumusan mengenai syarahan perdana yang telah disampaikan oleh Profesor Dr. Muhammad Rafie Johan sebentar tadi. Dipersilakan.
Wow. I'm sure a lot of new things today. Well, I think that was very interesting. I myself, I teach this critical thinking. So in my critical thinking, I ask some crazy questions. For example, we can imagine 3 dimensions, and we are convinced that time is the 4th dimension. It means time is also a given entity. So if you take time, it's only 3 dimensions, which actually you need the time to exist, right? So can we imagine 7 dimensions? Professor Raymond, can we imagine 7 dimensions? Is there such thing as 7th dimension? Okay, like this. Okay, I think I'm actually I read a lot of this astronomy and all that, a lot of things there where it says that even in our Milky Way galaxy, you go from one end to the end, it will take a few million light years to go there, right? And there is a dark matter and all that. So I think if you look from a quantum physics dimension, there's a lot of things can make sense, right? So if you don't have this knowledge on this quantum, what we were talking today, probably a lot of things will not look very logical. So from what I hear today, so time travel is a possible phenomena. Is that so? You see, 20, 30 years ago, if you say that you can send the whole book through email, that is not possible, right or not? I remember when I was doing my master, even when I was doing as undergraduate, even to get one paper, you got to go to the library, printing, this and that, right? But now we could send the whole book immediately to someone the other side of the world, right? You can reach someone over the phone within what, microsecond? So all this probably is an application of what has been spoken today. So one last thing before I conclude this is, we have this mental problem now. A lot of our own students are having this, a lot of mental issues. Mental means, you have stress, this and that. I hope one day this use of this, what you propose today, that we say that we look at human being as feelings and all that, where it can be manipulated for a good cause. So I hope this theory can be actually made into something practical for human being. It means where someone with mental illness, stress, or whatever it is, goes to a hospital, where this can be used to treat. I think there's a lot of application into this as well, and also for OKUs, those who are physically disabled. These things also can help actually rehabilitation. For example, you let your mind think that you can actually physically do certain things. So these are all something that can be translated into actual things. So I hope you will continue to do this, and you'll promote your student to do this. And I truly enjoyed. I'm sure rest of the audience here also enjoyed these things. Profesor, terima kasih atas Profesor Muhammad Rafie Johan untuk syarahan yang menyedarkan kita tentang fitrah ciptaan Tuhan dari sudut sains. And also you made us aware that there's a lot of application into this. Okay, thanks to all our previous scientists. Saya yakin ini akan memberi manfaat kepada semua hadirin hari ini. Dengan ini saya dengan besar hati dengan rasminya menutup majlis syaraan perdana ini. Assalamualaikum, terima kasih. Thank you.
Majlis mengucapkan terima kasih kepada Profesor Insinyur Dr. Abdul Aziz Abdul Rahman kerana sudi mempengerusikan carahan perdana pada pagi ini. Sebagai tanda terima kasih, majlis ingin menjemput Profesor Dr. Wan Jeffrey Basirun, Timbalan Pengarah NanoCAD, untuk menyampaikan cenderahati penghargaan kepada Profesor Insinyur Dr. Abdul Aziz Abdul Rahman. Terima kasih juga kepada para jemputan khas, barisan ahli akademik dan pengurusan NanoCAD, warga Universiti Malaya serta para hadirin kerana telah meluangkan masa pada pagi ini. Sebagai tanda sokongan dan ucapan tahniah, alumni dan ahli-ahli kumpulan penyelidikan kejuruteraan bahan nano ingin menyampaikan cenderahati kepada Profesor Dr. Muhammad Rafie Johan. Dipersilakan wakil. Majlis dengan ini menjemput semua hadirin untuk menikmati jamuan makan tengah hari yang telah disediakan di Dewan Makan bersebelahan auditorium ini. Dengan itu, berakhirlah sudah syarahan perdana oleh Profesor Dr. Muhammad Rafie Johan. Saya bagi pihak majlis memohon ampun dan maaf sekiranya terdapat sebarang kesilapan dan kekurangan dalam perjalanan majlis. Sekian, terima kasih dan salam hormat.
Saya tak berdiri cakap Allah kenapa Hafiz orang tak berdiri. Tak berdiri.
Biar aku tak fikir. Dia kendi ke? Habis dah cerita.
Tak masuk video Abi. Tapi duduk sini tak nampak sangat.
Dia kena beli ke? Kalau betul abang saya dengan tugas.
Ya, tapi tak ada makan non-stop. Nampak?
Sebenarnya apa-apa pun kalau dengan negara tu kau
Tengah buat
consider
kereta?
wajib lah orang kata.
Tengah bawa kereta?
Tengah buat kereta tu aku tak tahulah. Tak, maksudnya tengah event lah. Dia cakap, sudah Hafiz tak berdiri. Cakap dia seorang pula tu duduk. So aku nak kata dah. Sebab semua berdiri kan.
Oh, tak pasal tengok komputer tadi.
Sini. Nak?
Tuk. Oh.